Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss one of the GATE question which came in the year 1999 related to segmented paging. This kind of GATE questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. A computer system has segmented paging architecture for virtual memory. The memory is byte addressable. Both virtual and physical memory space is 2 power 16 bytes each. The virtual address space is divided into 8 equal segments. The memory management unit has a hardware segment table, each entry of which contains the physical address of the page table of the segment. Page table are stored in the main memory and contains 2 bytes page table entries. Now they are asking what is the minimum page size in bytes so that the page table for a segment requires at most 1 page to store it. Now they have given the question what they are asking, find the minimum page size. Now the question is related to segmented paging. Now let me give an overview about the segmented paging, then I will solve this numerical question. In segmented paging, the main memory is divided into frames. Okay, main memory is divided into frames and the process is divided into segments. Segment S0, segment S1, segment S2, segment S3 like that. And the segments may be of different size. But however, in this question they have given 8 equal segments, but in reality, usually the segment size will be vary. Now, each segment will be further divided into pages. Now, the page size will be equal to main memory frame size. Let's consider that here you have 1, 2, 3, 4 pages are there, and here you have 3 pages in the segment. In segment S2 you have 5 pages are there. Is it clear? Now each segment will have its own page table because the page number 0 of segment S0 will be stored in one of the frame. Similarly, page number 0 of segment 1, if it is there in the main memory, it will be stored in one of the frame of the main memory. So to avoid the conflict, each segment will have its own page table. Now the number of entries in the page table of segment S0, let's consider that this is the page table of segment S0. The number of entries in the page table of segment S0 will be equal to number of pages in the segment S0. Let's consider that number of pages are 4. So here the number of entries will be 4. The indices will be page number. You will have page number 0, page number 1, page number 2, page number 3, and each entry in the page table will consist of frame number and other optional bits such as dirty bit will be there, present or option bit will be there, cache enabled or disabled bit will be there, reference bit will be there, protection bits will be there. Is it clear? Now what we have to do, usually each page table will be stored in one of the frame in the main memory. Now, when it comes to the paging, as one process will have its own page table, we will store the base address of the page table in one of the register. Is it clear? So, whenever CPU want to execute particular instruction, it will fetch the page table from the main memory address because it will store in one of the frame. But here you have multiple page tables, so we cannot store the base address of the multiple page tables which are loaded in the main memory in a single register. We need multiple registers. So to overcome that one, instead of maintaining multiple registers to store the address, we will maintain one table called segment table. Now the segment table will consist of indices as segment numbers. Let's take the segment S0, segment S1, segment S2. So these are the indices of the segment table, and then you will have the base address of the page table. Segment S0 page table, base address will be there. Segment S1 page table will be stored in one of the frame in the main memory, so its address will be there. And S2 meaning is that page table 2, page table of segment S2 will be loaded in one of the frame of the main memory, that address will be there. Now this usually the segment table also will be loaded in one of the frame of the main memory, and that address will be stored in a register called segment table base register. Is it clear? So CPU will generate the logical address. The memory management unit will convert the logical address to the physical address. The physical address will be consist of frame number and then frame offset. The logical address will consist of segment number, page number, and then page offset. So the CPU will generate the logical address consists of segment number, page number, and page offset. The memory management unit will convert the logical address to the physical address consists of frame number, because main memory is logically divided into frames and each frame will have certain bytes of information, so that will be identified with the help of frame offset. Is it clear? So this is an overview about the segmented paging. Now let me solve this numerical question for you. Now if you read it, they said both virtual and physical memory space is 2 power 16 bytes. So you have the main memory is of 2 power 16 bytes. Is it clear? So you have main memory size is 2 power 16 bytes, and your virtual address space is also 2 power 16 bytes. Okay, and the virtual address space is divided into 8 equal segments. So number of segments is equal to 2 power 3, which is equal to 8. Is it clear? Are you able to understand? And you have the memory management unit has a hardware segment table. Each entry consists of physical address of the page table of the segment. That is okay. Page table are stored in the main memory. That is also we have discussed, and contains 2 bytes of page table entries. So they have given page table entry size. We have discussed that the page table will consist of frame number and presenter absent bit, cache enabled bit. All this size they have given as 2 bytes. So which is nothing but 16 bits are there to store the frame number and other optional bits. Now what they are asking, what is the minimum page size? So they are asking us to find the page size, okay, in bytes, so that the page table for a segment requires at most 1 page. We have discussed that page table of each segment will be loaded in one of the frame of the main memory. Is it clear? If the size of the page table can be less than the frame size, if it is greater, then we will go for the multi-level paging, because the page table will be again divided into pages and we will store the outer page table. Is it clear? But here they are saying it is a single level paging. So now what they are asking, page size, and we know that if page table size, we need to find the page table size such a way that it will be stored in the one page. Is it clear? Are you able to understand it or not? Because entire page table should be stored in one of the page. So page size will be equal to or less than or equal to page size. So page table size less than or equal to page size. Okay. So to do that one, first we need to find the logical address. The logical address is totally 16 bits, because they said main memory size or virtual address size is 2 power 16 bytes. So usually CPU generates the logical address which they have given as 16 bits. Okay. Now this will consist of segment number, page number, and page offset. Now remember one thing, the number of bits required for the segment number will depend on number of segments. Is it clear? Because if you have 8 segments, then you need 3 bits to represent each segment separately. How we will represent? If it is 8 segments, we'll represent 001 for segment S0, 001 for segment S1, similarly 111 segment S7. So we need 3 bits to represent the segment number of 8 segments, and we don't know the page number and page offset. Now remember one thing, the page offset will be depend on the size of the page. Is it clear? So we don't know the size of the page. So let me represent the size of the page as 2 power x. Then we need x bits to represent the page offset. If the page size is 2 power x bytes, then x bits are required to represent the page offset. And we don't know the page number bits. Why? Because we don't know the number of pages in each segment. Am I right? Because if we know the segment size and if we know the page size, we can easily find out the number of pages. So the page number will be depend on number of pages. Let's consider that number of pages are 2 power y. Then we need y bits to represent the page number. So this total one, x plus, let me write here, x plus y plus 3 is equal to 16. So which is nothing but x plus y is equal to 13. You represent somewhere here. Okay. We'll use this equation to solve the x value and y value. Is it clear for you? Okay. So with this logical address, we found that x plus y means the number of bits required for the page offset and page number will be equal to 13. But however, we don't know the individual bits. Okay. So now we know that general formula as, if they say that page table should be fit in one of the page, so I can say that page table size is equal to number of entries into entry size. Is it clear? So that page table should be fit in one of the page. So page size is equal to number of entries into entry size. They have given as page table entry size as 2 bytes. So let me write it as 2 bytes. Okay. So we know the page size? We don't know. We just represented the page size as 2 power x. So that's why we need x bits. So I can write it here somewhere. Okay. Let me write here only. I hope it is visible for you. 2 power x. Okay. Is it clear? Or let me erase this one. Sorry for confusing you, because whatever I am writing, it should be visible for you. That is my ultimate object. Okay. 2 power x is equal to, do we know the number of entries? I already discussed that the number of entries in a page table will be equal to number of pages in a segment. Am I right or wrong? So number of pages will be equal to 2 power y, because if we have the page number representing y bits, then number of pages will be 2 power y. So number of entries will be 2 power y is equal to, 2 power x is equal to 2 power y into 2 bytes, which is everything is in bytes. So let me make it as 2. So which is nothing but 2 power x is equal to 2 power y plus 1. So what I can say from here is x minus y is equal to 1. Am I right or wrong? Because x is equal to y plus 1. So x minus y is equal to 1. If I simplify this equation, I will get 2x is equal to 14. So x will be equal to 7. Okay. So if I simplify this equation, I will get the x value is equal to 7. Similarly, if I substitute the x value and try to find the y value, I will get the y value as 6. Is it clear? If you have a doubt, you can cross check it also. Is it clear? So x value is equal to 7 and y value is equal to 6. Meaning is that number of bits required for the page number will be 6 and number of bits required for the page offset will be 7. If 7 bits are required for the page offset, what will be the page size? Page size will be equal to 2 power 7 bytes. Similarly, number of pages will be equal to 2 power 6. Okay, so page size they are asking. What is the minimum page size? Minimum page size is 2 power 7, which is 128 bytes. Is it clear? Are you able to understand it or not? This should be the page size so that the page table of a segment will be stored in one of the page. One of the page is nothing but one of the frame in the main memory. Usually page table will be stored in one of the frame of the main memory, because we know that page size will be equal to frame size. They have written like this. I hope it is clear for you and you know how I have solved this question. If you still have any doubts related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.